Hello everyone, my name is Sheel. I hope you're doing good. Um, Today I'm going to try and address a topic that, in my opinion, is a problem with a lot of developers, especially big data developers, or rather the ones who are trying to get into the world of big data applications, um, and that is setting up a multi-node Cassandra cluster. And it can be a problem for various reasons. It can be a problem because um, you might want to install multiple VMs in your laptop, but a laptop has limited capacity. You cannot indefinitely keep adding number of cores or number of or the memory for that matter. So it slows down the host. And even if you have multiple machines, 9 out of 10 times for application developers, it becomes a bit tough to find the way around networking. And at the same time, it is as much important to run applications on a cluster in comparison to a single node setup, because yes, the single node setup is going to help you with the functional aspect of your story, but it will not be able to help you with the non-functional aspect of your story, which is, among other things, performance. So in this video, I'm going to show you how to set up a very simple multi-node cluster, a three-node cluster really on AWS Cloud. And we are going to write a very basic Spark application that pushes data into Cassandra. And that Spark application would be running on Amazon EMR. And we are also going to write a Java client that retrieves the data from Cassandra, the one that we wrote into it using Spark. And I should see that data in my Java client. So let's do that. Now I'm going to create three instances. That would be my three nodes for the Cassandra cluster. Let's do that. I'm going to click. I'm going to type in Ubuntu. And I'm going to spawn a T2X large machine, three of them. Mind you, it's not free, so exercise prudence while you choose your machine type. I'm going to spawn three of them, and I'm going to leave the rest as is. Add storage, just increase it by a tad bit. And now I'm going to create a security group. Now, this is something that needs attention. What this means is the Cassandra. So it's not even about Cassandra. In EC2, as you would know, that the machine is inaccessible by default. You need to open certain ports. So I know that I need to be able to SSH into this machine to be able to install Cassandra into it. That's one. I also know that I'll be having my Java client right on my machine, and it needs to talk to the Cassandra cluster. And I also know that the Amazon EMR, which will be hosting my Spark application, also needs to connect to the Cassandra cluster. So, three things here: SSH into the machine to be able to install Cassandra, connect to the machine, connect to the Cassandra cluster to be able to retrieve data for through my Java client. And the third thing is my Apache Spark application running on the Amazon EMR cluster, trying to connect to the Cassandra cluster. So I'm going to deal with the Amazon EMR part of it a bit later. Right now, I need to add two entries over here, but to keep it simple, I'm going to just allow all traffic from my machine only into this cluster. I click on launch, and it should launch 3 instances. So I now have my 3 instances launched. I'm going to provide them a name to be able to identify one from the other. Okay, so I have my 3 nodes up and running. All I need to now do is SSH into these machines individually and install Cassandra, and then configure each of them as required. And then when I start Cassandra, these nodes will talk to each other and form a topology, and from there the cluster is ready for consumption. So let's do that next. So I have my 3 machines ready. I have SSH'd into all 3 of them, Ubuntu 1, Ubuntu 2, Ubuntu 3. You can ignore this for the moment. I'm going to log into my first machine. That's 50209. So let's look for one. And here we are. So the first thing that I'm going to do is to do a sudo apt-get update to update all my packages. Now that this is done, I'm going to install Java. I need Java 8. I'm going to do a sudo apt-get install of Java 8. I'm going to type in openjdk. So once this is done, we are going to check the version of Java. Yes, it is Java 8. And I just need to look for the path where this has been installed so that I can set it up in my bashrc file. So lib, and I can just say usr libjvm, and there it is. So all I need to do is and this is my Java home. So I can now open my bashrc and export my Java home and the JRE and update my path. I'm going to go to the end of this file and paste my Java home and update my path. And I'm going to effect my change using source.bashrc. So with this done, all I need to do now is to do a wget on the Cassandra mirror. So I have my link with me. So that took some time. It does not typically take this long, but once in a while it does get a bit slow. So with the wget having been done, I am going to just check if it is there. Yes, the tar.gz file is there. I need to do a tar hyphen xvf on my tar.gz file, and this unpacks the entire bundle, and I can now do an ls to see that it has in fact been unpacked, and I can do away with my gz file. And this leaves me with the unpacked content only. And what I can now do is I can go to my Cassandra YAML, and this is where I make my changes. So this file involves some attention. So hear me out carefully. So in a Cassandra cluster, there are a bunch of settings that we need to be mindful of. The first one is the cluster name. This is obviously shared among all the nodes. So when I'm going to carry out these steps for node 2 and node 3, I need to make sure that the cluster name remains the same all through. The next is the listen address. The listen address is something that the nodes use to listen to each other, to be able to connect to each other. The port is 9160, and this can be one of your private IPs. And the third one is the RPC address. This is for your clients to listen, for your Java clients, for example, to listen to. So this is the address that your Java clients connect to. The fourth thing is something called as snitch. Now, snitch, the literal meaning of snitch in English is inform. So the moment we are talking about informing, we are talking about gossiping. And for those of you who know about Cassandra, they would know where I'm getting to. So the moment I talk about snitch, I'm talking about informing. Informing implies gossiping. Gossiping implies network topology. And the reason behind that is effective routing of requests. So for those of you who know Cassandra, you have a coordinator node which can keep changing from requests to requests. They need to be able to connect to the right node to fetch the data. So that's for the efficient routing of requests, and it is also used for efficient routing of replicas. So here the word efficient actually means around your cluster. So when you spread your replicas in multiple nodes, you need to make sure that it is evenly spread. And by evenly spread, what I mean to say is it should not be sitting, there should not be multiple replicas sitting on the same rack. For those of you who know Cassandra, again, you have this concept of racks and data centers. We need to ensure that one rack should not contain more than one replica. So, like I said, snitch means informing. Now, informing needs an informer, which needs certain rules or contract, which would mean in Java parlance an interface, and that interface is I-endpoint snitch. So, there are lots of snitches that Cassandra provides out of the box. So long as we are in AWS, we use the EC2 snitch. Now, the EC2 snitch uses the private IP addresses only. So this, of course, then means that I cannot be using it across regions. To be able to set up my Cassandra node across regions, I need to then use EC2 multi-region snitch. In our case, all of the three nodes have been set up in the same region. So I'm going to go ahead and use the EC2 snitch. So these were the bunch of settings that correspond to the Cassandra YAML file. Let's go ahead and start changing them one by one. I'm going to leave the name test cluster, and I'm going to proceed to listen address. I'm going to provide in my private IP address here. The next thing that I'm going to do is to go to my RPC address, and I'm going to use the same private IP address. If you have multiple IP addresses, private IP addresses, you might as well provide a separate one over here. I'm going to have one IP address, private IP address, so I'm going to use the same one. I'm now going to go to the EC2 snitch. I'm going to change this to EC2 snitch. And now I'm going to look for seeds which tells this node what are the other nodes that it needs to talk to. So here it is, and I'm going to replace this with the list of the 3 nodes that I have. And that is pretty much it in the Cassandra YAML. The next thing that I need to do is to go to the conf directory and look for the Cassandra rack.dc file. So this is the one, and all I need to do is to comment these two. So in essence, all I did was to not specify any rack or data center to keep things simple. So this was all that it took from this machine's side. So I'm going to do the exact same changes, the exact same set of changes in the other 2 machines, and I'm going to come back from there. All right, so I have made the exact set of changes to the other 2 nodes as well. And I'm going to start my Cassandra cluster. The command for that is Cassandra itself. It's in the bin directory. I'm going to click on, or rather I'm going to press the return key. And I'm going to do the same thing to the other 2 machines as well. Now, so all the 3 nodes have been started, and to check whether all 3 nodes have formed the topology, I'm going to run this command. All right. So now we can see that the cluster consists of all these 3 nodes. They have identified each other, and your Cassandra cluster is up and running. there was a small mistake that I had made earlier. The clusters, the nodes could not talk to each other because the clusters, all three nodes had the same security group because we spawned three of them. And I had given the SSH, access along with all sorts of traffic only from my machine. Now, for the nodes to be able to talk to each other, they need to have access to each other as well. So all I did was to go to the security groups of these machines, which is the same. All of them have the same security group. So I just went in over here and I allowed access from the same security group to the same security group. So now all the machines which have subscribed to this security group can access each other, and that's how they can connect to each other. So that in place, all that we are now left to do with is to write a sample Spark application and create an entry into the Cassandra cluster. And along with it, we also write a Java client, a sample Java client, which connects to the same Cassandra cluster and retrieves the value that the Spark application wrote. So let's do that now. So now we are in the Eclipse editor, and I am going to show you how to write a sample Cassandra application, how to connect to Cassandra from Java. Most of you would already be knowing this. I'm still going to go ahead and show this for those who don't already know about it. So, to be able to connect to Cassandra from Java, you need a bunch of dependencies. I have my Cassandra driver core, the query builder, and that's pretty much it. So that's all you need. And the first thing that I need to do is to go and create a key space. And once the key space is created, I will create the table. So I'm going to create a key space named TP. And I'm then going to create a table called EMP. So let's do that. I'm going to go ahead and run this program now. All right, the key space has been created. I can go to create the table now. I'm going to make changes to my IP address. I'm going to connect to one of the nodes, the public IP, and I'm going to hit on run. And the table is created as well. And if I were to write sample data into this machine, into this Cassandra cluster, let me try and doing that as well. All right, so the data has been created. So to be able to see whether the data was actually written to the Cassandra cluster, let me go ahead and retrieve the data. And there you go. The data is written in the Cassandra database, and we have been able to retrieve our results from the Cassandra cluster. So now with this done, the cluster is up and running. All I'm left to do with is to write a sample Spark application and come back here and run this read data program and check whether the data written by Spark is available over here or not. So let's do that. So here I am. I have written a sample Spark application. I'm going to run you by the list of dependencies that we have to download. We can skip most of them while we package them because it will be available in the EMR cluster anyway. But for the purposes of development, we have to still download these dependencies while we are doing the development. So I'm sorry. So Apache Spark, the Spark core library, the Spark SQL library, the Scala Lang library, and the Spark Cassandra connector. That's pretty much all we need. And we just need to ensure that the version that we use here, the Spark version that we use here, should be the version that we use while we spawn the Amazon EMR cluster as well. So with that said, I have gone ahead and written this very, very simple piece of Spark Scala code. All it does is write an entry into the EMP table in the TP key space that we saw earlier. So I have packaged my application and I have put it into my EMR master. So I can see this is the EMR master. Let me quickly take you to the EMR cluster that I have created. So this is the EMR cluster in front of us. And if you see the Spark version, it's the same 2.4.5. And I have connected to this master at 54, 165, 173, and 34, which is the same as this one. Let me show you in the EC2 instance screen as well. So this is the slave and we are connecting to the master right now. So the master would be this one, and 8827 ending is the one that we are connected to, which is 8827, and we have the Spark Cassandra jar over here. Now this EMR cluster, as I said in the beginning of the video, needs to be able to access the Cassandra cluster. For that, I need to allow the security groups which the EMR cluster has subscribed to the security groups which the cluster is subscribed to. So what that means is all the machines which have subscribed to all the machines which are a part of the EMR cluster will be able to access the machines which form the Cassandra cluster. So to do that, I will take you back to the security groups for the Cassandra cluster, and I have already added the security groups of the EMR master and the EMR slave. So what it means is that the cluster is going to accept requests from the EMR cluster on any of the ports in the Cassandra cluster. So with that said, I can now run my Spark jar on the EMR cluster so that it connects to the Cassandra cluster and writes an entry into the Cassandra file, only for us to be later be able to retrieve it from the Cassandra database in a Java application that we are connecting through from my machine. So let's do that. So I'm going to paste in the Spark submit command to run my Uber jar. And the job is started. And there you go. The job is completed. And hopefully the entry has been written into the Cassandra cluster. And we are going to now go to the Java client and see if we can retrieve the data. So let me run this program one more time. And I should be seeing this entry in the results. So I can see 47 Sarah and I can see 75 saw 1. So that's the proof that the Spark job was in fact able to connect to the Cassandra cluster and write records. And that with that, now that was the intention, and with that I would like to close the video. If there is anything, if there are any questions, do let me know in the comment section. If there is something you think I have not done right, please do let me know. It's always good to know the right way to go about things. I'll be waiting for your comments in the comment section. Thank you so much. Bye.